Okay, now we need to state the multiplicities of our roots. So previously, when we used the synthetic division to find our roots, it came out as 1, so x equals 1. So to put that more into a factored form, we can x minus 1, and now we're going to take that and divide it from our polynomial here. So x minus 1 is cubed, so fourth 1 is negative x cubed, cancel that out. This is negative x cubed plus 5x minus 8x plus 4. To get that, negative x squared equals cubed. And we have a plus x squared. Cross that out, and then 4x squared minus, we're going to do minus 4x and plus 4x, cancels out. And so now we're going to use this, our new polynomial, to find our multiplicities. And so first what we'll do is we'll factor this new polynomial that we have here to find our multiplicities. So we can use grouping. And then from our grouping, we can factor out GCS. And from here, have our x minus 1, we have our x squared plus 4, actually I have 2 of these. And so from this we can see that here we have a multiplicity of 2, and here a multiplicity of 1 for each of our roots, or actually a multiplicity of 2 for each of these roots. So now we need to find the minimum number of rational roots. So here I used the rational roots theorem, P over Q, P being the constant, Q being the leading coefficient, and the divisors are actually the factors of these numbers, and so my minimum number of rational roots would actually be 3 here. Next we need to list our x-intercepts here, and actually don't really need to solve anything because from looking for our multiplicities we have also found our roots, or our x-intercepts, being these two. So x equals 1 would be our x-intercepts, and the multiplicity of 2 at that point. Yeah. Alright, now to list or write the polynomial in factored form. I've done most of the solving already, and from my long division I just know that x minus 1 times x cubed minus x squared minus 4x minus 4. This is my factored form for this polynomial. Okay, here we have our graph, and now we need to find our zeros and state their multiplicity. So doing this graphing wise, click second trace, go to 2 to find our zeros, and then we enter in our left bound point, click enter, and we enter in our right bound point, click enter, and we would guess on that point, and that's the 0 that we're guessing on, and this has a multiplicity of 1, and we repeat the process for the other points. Clear that. Second trace, go to our zeros, and then first our left bound point, hit enter, our right bound point, hit enter, guess, and again that's the point in which we have calculated our 0 with a multiplicity of 2, actually a multiplicity of 1, and finally one more time, second trace, 2, all the way over here, plug in our left bound point, our right bound point, hit enter, and that's the guess given, and also seems as it has a multiplicity of 1. So we've found our zeros, and in doing so we've also found all our intercepts that we need. Now to find our extrema, or our absolute max, you go second trace, you go down to maximum, enter, and then go to our highest point here. Oops, made a mistake. did right bound first. Second trace 4. Our left bound point, our right bound point, guess on that, and that would be our absolute maximum. Now as well, to find our minimum, just clear this. Second trace down to 3, go all the way here, get a left bound point and a right bound point, enter, and that would be our minimum. Okay, now stating our domain and range for in interval notation. So for our domain, it'll just be parentheses negative infinity to infinity parentheses, and for our range, basically the same thing, parentheses negative infinity to infinity parentheses. Now to state the intervals in which our graph is increasing. So here we have a negative infinity all the way up to 2, and as well from our point down here, negative 7 up to infinity, and for our decreasing points we have that 2 down to negative 7. Alright, now last problem. So what I've done is I've plugged in this new function and evaluated, or I plugged it into the original function given, and I've evaluated the problem, and I got 4.75x plus 14, and from what it was previously, the new domain and range, for domain it's negative infinity to infinity, and range is negative infinity to infinity. And what I've done here is I've put both of the graphs side by side, putting the first graph in the y1, second graph in the y2, and then looking at both of them and seeing how the first one changed to the second one after evaluating the problem.